2.8, solving equations with fractions. So the goal here is to use algebra to maintain the equality and balance of equations. We're just going to solve equations. This time the equations have fractions in them. Okay, let's just look at some very basic examples here in part A. Here I have x over 3 equals 5. And remember the entire operations here, the procedure to solving equations is to use reverse operations or reverse BEDMAS. So when you see x over 3 equals 5, the goal is to isolate x, and to do so we have to get rid of this division by 3. And in order to do that, we apply the reverse operation. So we're going to multiply by 3. So we're going to multiply the left side by 3, and we're going to multiply the right side by 3. And we do it both to the left and to the right so that we can balance the equation. Okay. So by doing this, what happens is these 3's cancel. So 1 3 from the top and 1 3 from the bottom cancel, leaving me with just an x. And on the right side, I have 5 times 3, which is 15. And there's my answer. X equals 15. Now looking at this next example, again, I see a 2 over 3 times x equals negative 4. If we're going to be isolating x, we should be now trying to deal with this denominator. So the strategy I would employ here would be, now you can either multiply by the reciprocal of this fraction, or you can take it one step at a time and start by just multiplying by 3. So if I multiply the left side by 3, I'll also multiply the right side by 3. And the reason why I'm choosing 3 is because the 3 will allow me to cancel 3 from the bottom here in this fraction. Okay, so 3 canceling with 3 leaves me with just a 2 times x, and that's equal to negative 4 times 3, which is negative 12. Okay, and remember the goal is to still isolate for x, so I have to deal with this 2. So if I'm multiplying by 2, the reverse operation is to divide by 2. And you do it on both sides so that you can balance the equation. So here I should have 2 over x, 2x over 2 equals negative 12 over 2. So x's cancel, leaving me with x. Negative 12 over 2 is negative 6. Okay. All right. If you wanted to do this in one step, you could simply, let's rewrite this equation again. 2 over 3x equals negative 4. If I chose to multiply both sides by the reciprocal, 3 over 2 and 3 over 2, what can happen is that I can get these 3's to cancel from top and the bottom, and the 2's to cancel from top to the bottom, leaving me with x equals, and then multiplying negative 4 times 3 over 2. So negative 4 times 3 is negative 12 over 2, which is negative 6. Same answer. Our next example, p minus 2 over 5 equals negative 4. So now we're not multiplying any fractions in here, we're actually subtracting a fraction. So to isolate this variable, I have to now add the positive 2 over 5 so that I can cancel that. And then on the right side, I'm also adding 2 over 5. So negative 2 over 5 plus 2 over 5 is 0, leaving me with just p, the variable, on the left side. And here I have negative 4 plus 2 over 5, or I could say 2 over 5 minus 4. To subtract a fraction with an integer, I have to convert this number into a fraction. So I could say 2 over 5 minus 20 over 5. Because 20 over 5 is the same thing as saying 4. And this leaves me with an answer of, let's write it over here, so p equals negative, so 2 take away 20 is negative 18 over 5. All right, so how do we solve equations with multiple fractions? Well, you have 2 steps to do. So the first step would be to be writing all the fractions and numbers with the same lowest common denominator. And step 2, then we equate our numerators. Okay, this should say equating or equate numerators. Now, let's look at this example. 2 fractions, 2x plus 3 over 4 and x minus 2 over 3. Well, how do we get, the goal is to isolate this x. So I want to somehow get rid of this complicated denominator here at the bottom so it can make our life easier. Well, it turns out that we could just write these fractions with the common denominator. How would I do that? Well, 4 and 3. Well, 4 and 3 make 12. So if I want to write the denominator as 12, I can simply multiply this part by 3, multiply this entire numerator by 3, and I can multiply the bottom by 3, and multiply this numerator by 4, both the top and the bottom by 4, so that I can get 3 times 2x plus 3 over 12. And here I will get 4 times x minus 2 over 12. Okay, so our lowest common denominator is equal to 12. So what happens now? Well, it looks like I've gone from from simpler to more complicated. But in reality, if you're dividing both by the same number, then the numerators are going to be the same. Okay, so since, I'm going to say here, since the denominators are the same, they are cancelled. Okay, so when you cancel the denominators, what we get is just the numerators. 3 times 2x plus 3 equals 4 times x minus 2. Okay?
Oh, there you go, the class. See, I don't even remember. I don't remember.
So we have here no denominators anymore. And the next step would be to now solve for x, right? So we're going to solve for x, and we have monomials times binomials. These brackets are in the way. I have to now expand. So we're going to use our distributive property. So here we're going to say distributive, or distribute slash expand. Okay, so if I expand both the left side and the right side, I will get 3 times 2x, which is 6x, and 3 times 3, which is 9, so plus 9. And on the right side, I have 4 times x, which is 4x, and 4 times minus 2, which is minus 8. Okay, and now here is the situation where we have variables on both sides. So what I'm going to do is I'm going to subtract 4x from both sides. Now we're doing it on both sides so you can keep the equation balanced. And by doing so, what will happen is that 4x minus 4x is 0, and I have the minus 8 left over on the right side, and I have 6x minus 4x, which is 2x, and I have plus 9 on the left side. So now I've reduced this equation to one where the variable is just on one side. So my next step, again, reverse BEDMAS, order of operations, and before we do the multiplication, we have to deal with the addition and subtraction. So if I have plus 9, I'm going to subtract 9 from both sides. Okay, so here on the left side I have 2x, 9 take away 9 is 0, so I'm fine there with the equal sign. Negative 8 take away negative 9 is negative 17. So just filling in my steps here, I have subtract 4x on both sides, and here I subtract 9 on both sides. And then here, to get x, our goal is to isolate for x, so here I should be dividing by 2, and we'll do it on both sides, divide by 2. Okay. So 2 divided by 2 cancel out, I'm left with x, and negative 17 over 2 is just a fraction already in lowest terms. Okay, so here in this step, I'm just going to say that we are dividing 2 on both sides. Oh. And here we're going to leave our fraction in lowest terms. Okay. So let's move on to some examples. So let's solve an equation like this. Oh, actually, before I go to another example, let me show you a little shortcut. Whenever you have a fraction like this, where you have just a single entire fraction as an expression on the left and a single entire fraction as expression on the right, you can skip one step. You can skip this LCD step by simply cross multiplying, bringing the 3 up to the top here and bringing the 4 up to the top here, leaving you with what we have here on this line. Okay? And although it's a nice shortcut you can use, you can't always use it when solving equations with fractions. So it's often best to just look for that lowest common denominator first. So showing me that you're getting the lowest common denominator and then canceling the lowest common denominator out. Okay? So let's show you this through some examples. So example 1, here's an equation. On the left side, I have the addition of two fractions. Okay, so I have to find the lowest common denominator here between 2 and 5, which is 10. Okay, so I'm going to convert the entire equation into fractions with the denominator of 10. So I'm going to say here the LCD is equal to 10. So converting x over 2 as a fraction out of 10, that would be 5x over 10. So I multiply the top and bottom by 5. For the next one, I can convert this to, then multiply the top and the bottom by 2. So I'll have 2 times 2x on the top over 10 on the bottom. And equal sign on the right side, if I want the denominator of 10, I better multiply both the top and the bottom by 10. So negative 3 times 10 over 10. Okay. Now when the entire equation has the same denominator, you can just cancel them all out. Okay. You might wonder, why can I do that? Well, imagine just taking two fractions. If I said 1/2 equals 1/2, it's the same thing as saying 1 equals 1, right? Because you could just cancel out the fractions. They all reduce. Okay. Now, same thing if I were to say, maybe a better way to explain it is, imagine me taking this entire equation and I multiply everything by 10, both the left side by 10 and the right side by 10. So if I multiplied the left side by 10, so 10 times, and multiply the right side by 10, what would that do? Well, imagine the distributive property. The distributive property says, well, multiply the 10 with each of the terms inside. The 10 will just cancel out with the 10, and this 10. And this 10 will cancel out with this 10. Okay? So I'm multiplying 10 on both sides to balance the equation, and by doing that, I can cancel out those 10s in the bottom. So what I'm really left with is just what I have in the numerators. Okay, so 5x plus 4x equals negative 30. Okay, 9x equals negative 30. So now I'm just collecting the like terms on the left side. And if I continue solving this, isolating x, I need to divide by 9 on both sides. So x equals negative 30 divided by 9. And reducing this into lowest terms, I have x equals negative 10 over 3. Okay, next example. Let's go down to b. So p over 3 minus 2 equals 6p over 5. So here I have denominators of 3 and 5. They are different. So I want to find a common denominator. So I'm going to multiply 3 times 5 to get 15. So my lowest common denominator equals 15. Okay, so here what I'm going to do next is rewrite each fraction, each term as a fraction out of 15. So the p over 3 becomes 5p over 15 minus 2 times 15 over 15. So multiply the top and the bottom by 15. And that equals, multiply the top and bottom by 3. So 3 times 6p over 5 times 3, which is 15. Okay. And again, now that your denominators are all the same, they can cancel each other out. And the reason why is because imagine that you're multiplying both the left side and the right side by 15, and those 15s will cancel from the 15s on the bottom. Okay, so this reduces to 5p minus 30 And that equals 3 times 6 is 18p. Okay. And now I have an equation with two variables on both sides. I mean, a variable on both sides. So I have to reduce this. I can do it by subtracting 5p from the left, so minus 5p, as well as subtracting 5p on the right. Okay, so these two cancel. I have negative 30 equals 13p. And if I divide this side by 13 and this side by 13, I'll get my answer. And it's all right to put the variable on the right side, so I have p over here like this. Negative 30 over 13 would be my final answer. Okay? And just to make sure we write this in proper form, you can commute both sides, so you can just express this as saying p equals negative 30 over 13. Okay, moving on to example C. So here's an equation with three terms, all with a different denominator, 3 times 4 times 2, but I can identify a common denominator of 12. LCD equals 12. So I'm going to convert every fraction into a fraction out of 12. So y minus 2 over 3 becomes 4 times y minus 2 over 3. So I multiply the top and the bottom by 4. So 4 times y minus 2 over 12. I think I said 3, so it should be 12. My next expression, my next term here, if I multiply the top and the bottom by 3, I'll get a denominator of 12. And the top I have to multiply by 3, so 3 times y minus 7. It's important that you remember what I said about fractions. There's an invisible bracket. There's an invisible bracket around what you have in the numerator and the denominator. So if I have multiple terms in that numerator, I have to put a bracket around it when I multiply that by 3. And then I'm going to expand it afterwards. Okay. On the right side, if I want to get a denominator of 12, I have to multiply 2 times 6. So I multiply the top by 6 as well. So I get 6 times y. Now that I have a common denominator, I can cancel them out. And that leaves me with 4 times y minus 2 minus 3 times y minus 7 equals 6y. Okay, now we have this long, complicated equation to solve here. Before we can isolate any y's, we have to do a little bit of expanding. So we have a monomial times a binomial, and we have a monomial here times a binomial. So you have to expand using the distributive property. Okay, so here I'm going to write 4 times y, which is 4y. Then I have 4 times negative 2, or minus 2, which becomes minus 8. Then be careful with this minus sign, so I have a minus 3 times y, which is minus 3y. And then I have a minus 3 times minus 7, which is a positive 21. So this becomes plus 21, and that equals 6y. Okay. Then let's collect some like terms. So 4y minus, take away 3y is just a single y. And here I have negative 8 plus 21, which is 13. So plus 13. And that equals 6y. I still have a variable on both sides, so what I'm going to do is subtract 1y from each side, so minus y over here, and to balance it, minus y over here. And as those two y's on the left side go away, I'm left with 13 equals 5y. My final step would be to divide both sides by 5. So divide this side by 5, divide this side by 5. These two cancel. And I'm left with y equals 13 over 5. And just to put it in proper form, put the y first, so y equals 13 over 5. Moving on to part D. So here's another fraction in another equation with the two fraction terms in it. There should be a bracket around the x minus 2. So let's put a bracket around the x minus 2. And I'm going to find a common denominator. So it looks like 4 and 3 will make a common denominator of 12. So LCD equals 12. Okay, so the first term, if I multiply the top and the bottom by 3, I'll get 3 times x minus 2. Keep the brackets there. Denominator becomes 12. Minus. If I multiply the top and the bottom by 4, I'll get 4 times x minus 7 over 3 times 4, which is 12. And on the right side of my equal sign, I will have 1 can be represented with 12 over 12. Now that I have the common denominators of 12, I can cancel them all out, leaving me with what I have left in the numerator. So 3 times x minus 2 minus 4 times x minus 7. Now remember to keep your brackets, equals 12. So now we're back to this equation where we have these monomials times binomials, monomial times binomials. So I have to now expand using the distributive property. Okay, so whenever you see those brackets, again, and something multiplied in front, you have to expand using the distributive property. Okay, so then we have, let's do this. So 3 times x, which is 3x, 3 times minus 2, which is minus 6, and then we have, remember the minus sign in front. So if you prefer, you can separate them with pluses. So we do minus 4 times x, and then plus minus 4 times minus 7, which equals 12. Okay, then we'll simplify a little bit. So 3x minus 6, negative 4x is, so minus 4x, and then we have minus 4 times minus 7, which is positive 28, equals 12. So 3x minus 4x is just a single x, sorry, a negative x, and then negative 6 plus 28 is plus 22, and that equals 12. And then remember, you have to still isolate for x, so I have to get rid of this 22, so I have to subtract 22 from both sides, leaving me with negative x equals 12 take away 22 is negative 10. Now if I have a negative x equals negative 10, if I multiply both sides by a negative 1, I can convert my x into a positive value. So x equals positive 10. Okay, our last example. Oh, the big fish here. Okay, lots of terms with fractions and lots of different denominators. Can you identify a common denominator? If you said 24, you would be correct. So I'm going to use the LCD of 24. Okay, it cannot be 8 because 8 is not divisible by 3, although it is by 2 and 4, but it can't be by 3. So you have to look at something bigger, and 24 is that number. So convert every single one of these terms into a fraction with a denominator of 24. So here it is. 3 times 2 minus d, so the top and bottom by 3, make 24. Minus, for the next one, we're going to multiply the top by 12. So 12 times d plus 3 over 24 equals, here with the denominator of 3, I'm going to multiply the top by 8. So 8 times d minus 1. The bottom will become 3 times 8, which is 24. And the last term here, to get from 4 to 24, I multiply the top and the bottom by 6. So 6 times d minus 5 over 24. And now that all the denominators are the same, I can cancel them out. And the reason why is, imagine multiplying both the left side by positive 24 and the right side by positive 24, that those will be canceling out the 24s in the bottom. Okay, so I have 3 times 2 minus d minus 12 times d plus 3 equals 8 times d minus 1 minus 6 times d minus 5. So then I expand using the distributive property. So 3 times 2 is 6. 3 times minus d is minus 3d. Negative 12 times d is minus 12d. Negative 12 times 3 is minus 36. Equals 8 times d is 8d. 8 times minus 1 is minus 8. And then here, this one, minus 6 times d is minus 6d. And then minus 6 times minus 5 is positive 30, or plus 30. Now we have this long equation with a bunch of like terms. Collect the like terms on both the left and on the right. So on the left, minus 3 take away 12 is negative 15d, and 6 take away 36 is negative 30, or minus 30. On the right side, I have 8d take away 6d, which is 2d, and negative 8, or minus 8 plus 30 is 22, so plus 22. All right, now I have the variable on both sides of my equation, so I have to now subtract well, I'm going to choose to get rid of this 2d, so I'm going to subtract 2d from both sides, so minus 2d from here, and minus 2d from here. So these two cancel, and I'm left with 22 on the right side. On the left, negative 15 take away negative 2 is negative 17d minus 30. If I add 30 on both sides, I can sort of work my way to isolating this term right here. So these two cancel each other out. On the right side, I have 22 plus 30, which is 52. On the left, I have negative 17 times d. And if I divide both sides by negative 17, I'll get my answer. So this cancels out. I'm left with d by itself and negative 52 over 17 on the right side. And there you go. Those are just a few examples of working with fractions inside your equation. Just to go back up here one more time to understand my original example. So again, the reason why, since the denominators are the same, they are cancelled. So imagine multiplying both sides by 12. Okay, that's what allows me to cancel those 12s and cancel these 12s. And that's why they disappear.